Welcome back. In our last lesson, we demonstrated the ball and ring experiment to show that solids expand when their temperature is increased. Today, we are tackling a phrase that makes many physics students panic: linear expansivity. It sounds incredibly complicated, doesn't it? But let me let you in on a secret. It is just a fancy scientific way of saying change in length. That's it. Linear means along a straight line, and expansivity just tells us how much it expands. So whenever you hear linear expansivity, just think, how much longer does a solid get? Now, metals don't all expand by the same amount. Iron expands differently than copper or aluminum. To compare them fairly, scientists had to set a few strict conditions. Think of it like a game with two simple rules. Rule number 1, we must start with a standard length. We call this a unit length. To keep things simple, let's use the standard SI unit, exactly 1 meter of our solid metal bar. Rule number 2, we must change its temperature by a standard amount. We call this a unit temperature change. We will heat our bar by exactly 1 degree Celsius or 1 Kelvin, which is the exact same step up in temperature. We take a solid metal bar that is exactly 1 meter long. We heat it up by exactly 1 degree Celsius. Because it's a solid being heated, it expands. That tiny fraction of a millimeter change in length, that is the linear expansivity of that metal. It is literally just a fraction of a meter that a 1 meter solid expands when you give it a 1 degree temperature boost. If you know this number for copper, you can predict exactly how much a massive 50-meter copper wire will expand on a hot summer day. And guess what? It works perfectly in reverse too. If you decrease the temperature of that 1 meter bar by 1 degree, it will contract and shrink by that exact same tiny fraction. So let's put our rules together. So forget the scary jargon. Linear expansivity is just nature's rulebook, telling us exactly how much a 1 meter solid expands or shrinks for every single degree of temperature change. In our next lesson, we'll look at the simple formula we use to calculate this. And you'll see it's as easy as basic arithmetic. See you there.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.